New nanotech will empower a solid, electric flow creation inside the human body. Another nanotechnology improvement by a global examination group drove by Tel Aviv University specialists will make it conceivable to create electric flows and voltage inside the human body through the initiation of different organs, mechanical power. The analysts clarify that the advancement includes another and exceptionally solid organic material, like collagen, which is non-poisonous and makes no mischief the body's tissues. The scientists accept that this new nanotechnology has numerous likely applications in medication, including collecting clean energy to work gadgets embedded in the body, like pacemakers, through the body's normal developments, dispensing with the requirement for batteries. The examination was driven by Professor Ehud Gazit of the Shmonis School of Biomedicine and Cancer Research at the Wise Faculty of Life Sciences, the Department of Materials Science and Engineering at the Fleischmann Faculty of Engineering and the Center for Nanoscience and Nanotechnology, alongside his lab group, Dr. Santu Bera and Dr. Wei Ji. Likewise participating in the examination were analysts from the Weizmann Institute and various exploration foundations in Ireland, China and Australia. Because of their discoveries, the specialists got 2 ERC-POC awards pointed toward utilizing the logical examination from the ERC award that Gazit had recently won for applied innovation. The examination was distributed in the renowned diary Nature Communications. Professor Gazit, who is likewise founding director of the Blavatnik Center for Drug Discovery, clarifies, "Collagen is the most common protein in the human body, establishing about 30% of the entirety of the proteins in our body. It is an organic material with a helical design and an assortment of significant actual properties, like mechanical strength and adaptability, which are helpful in numerous applications. Notwithstanding, on the grounds that the collagen atom itself is huge and complex, scientists have for some time been searching for a moderate, short and basic particle that depends on collagen and shows comparable properties." About 18 months prior, in the diary Nature Materials, our gathering distributed an investigation in which we utilized nanotechnological intents to design another organic material that meets these prerequisites. It is a tripeptide, a short atom called Hyp-Phi-Phi comprising of just 3 amino acids, fit for a basic interaction of self-gathering of shaping a collagen-like helical construction that is adaptable and flaunts a strength like that of the metal titanium. In the current investigation, we look to analyze whether the new material we created bears another element that describes collagen, piezoelectricity. Piezoelectricity is the capacity of a material to produce electric flows and voltage because of the use of mechanical power, or the other way around, to make a mechanical power as the consequence of openness to an electric field. In the investigation, the analysts made nanometric constructions of the designed material, and with the assistance of cutting-edge nanotechnology apparatuses, applied mechanical tension on them. The test uncovered that the material does without a doubt create electric flows and voltage because of the pressing factor. In addition, minuscule constructions of just many nanometers showed perhaps the most significant level of piezoelectric capacity at any point found, practically identical or better than that of the piezoelectric materials generally found in the present market, the majority of which contain lead and are thusly not appropriate for clinical applications. As indicated by the scientists, the disclosure of piezoelectricity of this greatness in a nanometric material is of extraordinary importance, as it exhibits the capacity of the designed material to fill in as a sort of minuscule engine for little gadgets. Then, the analysts intend to apply crystallography and computational quantum mechanical techniques, thickness utilitarian hypothesis, to acquire an inside and out comprehension of the material's piezoelectric conduct and accordingly empower the precise designing of gems for the structure of biomedical gadgets. Professor Gazit adds, "The greater part of the piezoelectric materials that we are aware of today are poisonous toxic materials, or polymers, which means they are not earth and human body accommodating. Our new material, notwithstanding, is totally organic, and consequently appropriate for utilizes inside the body. For instance, a gadget produced using this material may supplant a battery that provisions energy to inserts like pacemakers, however it ought to be supplanted occasionally. Body developments, like pulses, jaw developments, solid discharges, or whatever other development that happens in the body consistently, will accuse the gadget of power, which will constantly actuate the embed. Presently, as a component of their proceeding with research, The analysts are looking to comprehend the subatomic instruments of the designed material, fully intent on understanding its colossal potential and transforming this logical disclosure into applied innovation. At this stage, the attention is on the improvement of clinical gadgets, yet Professor Gazet stresses that harmless to the ecosystem piezoelectric materials, for example, the one we have created, have gigantic potential in a wide scope of regions since they produce environmentally friendly power energy utilizing mechanical power that is being utilized in any case. For instance, a vehicle driving down the road can turn on the street lamps. These materials may likewise supplant lead-containing piezoelectric materials that are right now in far-reaching use, yet that raise worries about the spillage of poisonous metal into the climate.